Hi guys, this is SnackOverflow and we are here to explain our project ZKombinator. DeSci research involves a lot of institutions that collaborate together to perform research. They make use of algorithms such as the homomorphic encryption, federated machine learning, just to list a few. However, seeking funding for DeSci research is still extremely hard. Why? Because even though many institutions are collaborating together to perform research, they're still not able to reveal their internal sensitive details, such as their revenue, their breakthroughs, their methodologies, or anything else. So the core issue here is how are we supposed to receive this funding without having to submit sensitive information? That is where we come in as a platform. We ensure that each research lab or research institution is able to calculate the fair distribution of the funding without ever having to reveal their internal details such as their revenue, their expenses, their employees, their research to the public or to the other participating research labs. We focus on the funding so you can focus on the research. Okay, so now I'm going to show you an overall workflow of our application. So firstly, all the research institutions apply for funding on ZKombinator. There will be an admin who starts a secure room. What does he do in this room? Once he starts the room, he puts in the amount that's there for funding through a smart contract that's deployed on the Edu chain. This is basically similar to an escrow contract. So what happens is all the research institutions that are willing to participate in receiving funding join this room, and after that the admin signals that the BGW computation should start. So during this phase, all the connected nodes in the room, they perform the BGW computation locally on using their internal information as well as some information that they receive from the other connected nodes in a secure fashion. Finally, after all the secure BGW computation results are declared, the winning parties, which means all the parties that have received any sort of funding in any proportion, receive their funds straight into their wallet through another smart contract. This is basically what happens behind the scenes. Okay, so now I'm going to explain the BGW algorithm that we have implemented. We have basically abstracted our functional output, which in this case is the funding distribution calculation, as an arithmetic circuit. To this arithmetic circuit, we are supposed to input some numbers, which actually are supposed to be the internal revenue details. But as I've mentioned before, we are not allowed to share these details. So what do? We use an algorithm known as Shamir's secret sharing algorithm in order to break our revenue details into secure shares. Using these shares, we don't leak any information about our revenue, but we can use these shares in order to calculate our arithmetic circuits in a secure fashion. The only caveat is that we need to send over these shares to each other in a very secure fashion. That means only end to end should be done. For this, we are making use of a socket IO server like this. Basically, every node should have a secure connection to each other, which is basically the description on the left hand side. But to do this would require a lot of overhead. So instead, what we have implemented is a socket IO server which is encrypted end to end through RSA public key private key encryption. So this is done. Now where does the zero knowledge part come in, right? We have calculated our BGW circuit on every local node. How are we supposed to know whether a person is lying about their circuit calculation, right? They could easily change their circuit calculation and just tell that I have calculated this way when they haven't actually done it that way. That's where our zero knowledge proofs comes in. We basically prove that the arithmetic circuit has been calculated in the appropriate way without changing anything about the numbers themselves or the intermediate inputs or anything as such. This way, these ZK proofs are generated using Snark.js on the client side and sent over to the zkVerify chain to be verified and stored on chain for further verification in an easy way. Okay, so now since the explanation of our thing is over, we're going to show you a demonstration of ZKombinator. So this is the landing page, and here obviously we can click apply now. And
we have also added authentication with OpenCampus ID. So when institutions are doing decentralized research, since it's on EduChain, they'll have all of their stuff here like POAPs, a lot of the user tokens and all of the other details which you can use on our application by authenticating with your OpenCampus ID. So let's just create a new account on a new Gmail. So here we have the OTP. We'll use this and we'll create a new account with OpenCampus. So let's just follow so we have built this on the sandbox environment because we are not whitelisted as localhost obviously. So let's just follow the onboarding workflow provided by OpenCampus. It was fun integrating this into our app. Let's just put the first name, last name, and then some other details. Once we have authenticated ourselves with OpenCampus ID, we can use all of the authentication methods provided by them within the application as well. So let's create a profile, and this should redirect us back to our application's dashboard. Yep, so now we have come here. Now let's go to, now we'll simulate this computer as a admin and this one as participants trying to get funding. So these are the different institutions, and this is the funder. So let's just go to a new room where we can provide funding. Let's connect with our wallet. So let's just use MetaMask on EduChain to do the funding, right? So the way this works is the funder provides the fund to the room, and then the participants will join the room, and we'll have certain internal metrics, which is not, the participants have already uploaded the file, but there are certain internal metrics.
Okay, so now the MetaMask integration has been done on the admin side, and we are going to be adding participants to this room. In this case, since we are using socket connection, even on the same browser, a different tab represents a different device. The only difference will be that since we're using the same browser for demonstration purposes, it'll be showing the same wallet address, though on different devices it'll be showing different wallet addresses. Okay, so now since we're using live sockets, the moment you join in the room, you'll be able to see the current participants as well as the pooling amount and the number of participants, both on the admin side as well as the funding side. Now I'm going to be adding in roughly 5 to 6 members into this room. And like I said before, each tab basically represents a new device since we're using live sockets. Alright, so now we have 5 participants who are participating in the round, and we'll be adding funds to the room first, which is basically the funder adds the funds. So how is he going to do this? He's going to click the add funds to room button, and by doing this, a transaction will be sent to the smart contract that's running on EduChain. So it will just prompt him for his MetaMask integration, and yeah. Okay, so now the funds have successfully been added to the room. Now the next thing is, the admin can start the round. What happens when he clicks this? The BGW computation runs on each device. Then a zero knowledge proof is created by Snark.js, which is then sent over to zkVerify's chain using subwallet in this case, because we're using ACME tokens, and this gets stored on chain for further use. So we just click start run, and the BGW computation has started running. Simultaneously it asked me for the proof generation. So I'm just going to click approve, and since each tab is a new device, I'll have to click 5 times on the same wallet since we're using the same browser, but on different devices it will give different ones. So now the BGW computation has run, and yeah, so he has basically won the round, and you just click claim funds, and yeah, so once you do that, you can basically claim your funds. So confirm, and your funds would have been claimed successfully. It'll take a little while to render on this thing, but yeah, you can essentially see that the funds have been deposited. And it has also updated it here. So that's basically ZKombinator for you, and yeah, that's pretty much it.